This is part 5 of section 1.6. We've been composing these functions and talking about the domain. Now on this one, because this one does get kind of ugly, I want to remind you a little bit of the algebra as we go along. And since they do get ugly, I'm only going to worry about 2 of the 4 we have been working on. I'm going to do G composed with F, and I'm going to do G composed with G. Let's look at the domains. Right here, we have 2x minus 1 in the denominator. So this tells me that my x is not going to be allowed to equal positive 1/2. I could write out the whole domain for this right now, but this is enough to keep me going. This is enough to tell me what the domain is so that when I need to write it all out, I've got the information. And right here, this x cannot equal 0. So f of x has this restriction, g of x has this restriction. So let's find g composed with f. G of 1 over 2x minus 1, which is, you're going to have a complex fraction here. Okay, now you have some options on this. I could have, in the very beginning, rewritten g of x as 1 divided by x squared. Same thing as the fraction, and it would have made it look a little bit prettier. I could do the same thing here as 1 divided by this in parentheses, and that's definitely a good option when you're working problems like this. For right now, I'm just going to do this the long, hard way where things get complicated so that you can remember it all and then make your own adjustments as you see fit. If I square a fraction, you get to square the numerator and the denominator. So that's 1 squared, which is still 1, over 2x minus 1 squared. Okay. There are a couple of ways of proceeding from here. Some people do write it as a division problem, but you can also clear this denominator by multiplying the top of the bottom of the big denominator by that value. And this is over 1, and that cancels out right there. So what do I have here? Simply 2x minus 1 squared. Okay, so the domain. I need to look right here and right here. This is a quadratic by itself. It has no restrictions. This, however, had a restriction. So even though the issue appears to have gone away here, we still have to be aware of it. So my x still cannot equal 1/2. So that means the domain for this one will be negative infinity up to 1/2, parentheses, union 1/2 to infinity. Now let's do g composed with g. So this is g of 1 over x squared. Another option would be to write 1 over x squared as x to the negative 2. Just depending on what makes your life easier. So this would be taking this, plugging it in here, 1 over x squared, which is simply x squared. Squared. Yeah, that was an important part. I had to square the denominator. Okay, so this is x to the 4th. X to the 4th, perfectly good. No issues with the domain here, but we do have to look here. And we are still not allowed to equal 0. So this domain will be from negative infinity to 0, union 0 to infinity. Okay. Now we're going to talk a little bit about decomposing functions. And this really is one of the most important skills you can have in calculus, because one of the first things you learn about derivatives is the power rule, and you need to be able to figure out how to decompose the functions in order to use that. Okay? So basically what we're going to be doing on these types of problems is we're going to be given some function that is already the answer to a composition, and we want to take it back apart. Okay? So we're looking for f of g of x based on this. Well, I see that I have an absolute value function, and I have a linear function inside of that. So my two pieces, this part is going to be your g of x because it's the part that got plugged in. And what do we plug it into? The absolute value. So this would be our f of x would be simply the absolute value of x. You can double check that. If I figured f of g of x, I would be taking g of x and plugging it into f of x, and that's exactly what I have. Okay, let's do the same thing here. I have the square root of 3x squared plus 5. Okay, so what all do I have here? I have a square root, which is one of my basic functions, and inside the square root, I have a quadratic. So since the quadratic is inside the square, the quadratic is going to be my g of x. So that's 3x squared. And then what do we plug that into? F of x, which would be the square root of x, because that got plugged in here. And don't forget the plus 5. And also, when you're typing these in, make sure that this plus 5 is out from underneath the radical bar. It's definitely going to count it wrong if it's not.